Okay. Can I start? You want? Yeah. Okay. All right. So. Yeah. Good. Suboor, is that okay, everyone?
Can you stand a bit
everyone?
further away, maybe?
Yeah. Here.
A bit further. There you go.
Can I be seen in that? Yeah. Okay. Cool. Yeah. Okay. Cool. All right. So we're going to debate evolution and whether humans and chimps share a common ancestor. The reason this is a particularly important aspect of evolution because it's the aspect that Suboor has said is the thing that Islam is clear about didn't happen, and I think the evidence is clear that it did happen. So I'll just present a little bit of evidence. There's lots of it. We've got evidence from genetics, from paleontology, from archaeology, from biogeography, many fields of study. I'll just start with like one paper that's very important. It's this paper here. It was in Nature. It's the sequence of the chimpanzee genome, and it's done by the Chimpanzee Consortium, Genome Sequencing Consortium, and many of the world's leading genomic institutes signed off on this paper, and this is what they said. They said more than a century ago, Darwin and Huxley posited that humans share recent common ancestors with the African great apes. Modern molecular studies have spectacularly confirmed this prediction. So, you know, they don't usually have in science journals like quite such strong language, but the reason it's strong is because we really do have spectacular evidence for it. So let me give you just a couple of examples. So there are genes that get duplicated, and when they get duplicated, they can malfunction. They can lose their original function, shall we say. And these are called pseudogenes. And if you look at the chimp genome, there's many pseudogenes there. Just take one example. There's a pseudogene called nanog, and if you look at how many pseudogene copies they have, the chimpanzee genome has 10 pseudogenes of nanog. So if you like, these are like shared errors. So imagine someone hands you some homework, and then the teacher goes, hang on, I know that guy's older brother, and he handed in a very similar piece of homework 2 years ago. How would you know if you copied it? Well, if they had the same typos, you know, that would be very good evidence that it's been copied, or they'd have the same source. And this is what we're talking about here. They've got the same errors in the same locations. And that's very hard to explain if evolution is not true, but if evolution is true, perfectly explained. Now, if you look, these are the nanog pseudogenes.
Okay, one sec.
Let me just finish this point, okay, and then come back, okay? So you can see that they're at the same locations, same errors, but there's one nanog pseudogene that humans have that chimps don't have. Okay, that is nanog P8, not present in the chimpanzee genome. Now, if evolution is true, there's one way to explain that, and that is nanog P8 must have become a pseudogene after we split with chimps. So now what we can do is use molecular clock technology, and we can see if that's true. If evolution is true, that must be true. So they looked for that, and this is what they said. Human nanog P gene is located on human chromosome 15. It is the most recent of the nanog process pseudogenes, exactly as evolution predicts. But evolution can make a more precise prediction, because these pseudogenes, some of them are more than 100 million years old. They could be any age, really. But if evolution is true, nanog P8 must be younger than the human-chimp split, and that's estimated to be about 6 million years ago. So we use molecular clock technology, and we see how old it is. If evolution is true, it must not be older than 6 million years. And here's the estimate. Here's the paper. It says it's between 0.9 and 2.5 million years old, just as evolution predicts. But we can go even further than that, because of that age. Now we know that age, we can say this. Oh, they've now sequenced the Neanderthal genome. And we can say, well, once we've got that genome sequence, when did Neanderthals and humans split from each other? And that answer is between 400 and 700,000 years ago. So if that's true, then it must be the case that nano-P8 is in the Neanderthal genome. And we don't know this a priori. It might be true, it might not be true, but if evolution is true, if humans and chimps share a common ancestor, we should find nano-P8 in the Neanderthal genome. And here's the paper. As you can see, nano-P8 is present in the Neanderthal genome. So that's one piece of evidence. We can go, I've got loads more, but I don't know if you want to respond to that.
So, the position which I'm defending today is that human chimp ancestry, it's been projected to the public like this is a fact, like this is true. And in the way that Phil just explained right now, that they have spectacular evidence that it's actually true. Now the case I'm going to be making is quite simple. It is that human chimp ancestry is not true literally. It is not a fact in the absolute sense, in the sense that it doesn't change and that it cannot be corrected due to future information. It is a scientific hypothesis which is based on a probabilistic framework which has assumptions, and there can be core disputes about it. Now, let's just go back to your first slide, because you said a lot of things. I want to deal with each one at a time, right? So let's go back to your first slide.
Sure.
And the way we're going to do this is that once he makes a point, then I'm going to address those points, and then he can carry on make new points.
Okay,
go back.
Fine, yeah. There you go.
First slide, first slide.
Sorry, yeah.
First slide. Your first slide, your first slide.
Oh, okay.
Right.
This, yeah.
So just give me that for a second.
Sure.
So the first thing that Phil did, and I think this is very important, is that he basically said this is the evidence for human chimp ancestry. He spoke about genetics, paleontology, archaeology, biogeography, right? Now these are different fields. Now the first point to make is any scientific conclusion in any scientific field can be revised based upon new information. So for example, you were mentioning about pseudogenes. Another piece of evidence which was used apart from pseudogenes was junk DNA. Junk DNA was used as evidence that we have natural selection responsible for leaving behind all this extra junk. Natural selection, the way it works is it's a very wasteful process. It's a process which punishes for, it rewards for a slight incremental advantage, and it punishes for something which is wasteful. Now, when it actually comes to junk DNA, we later on discovered that that wasn't actually junk. Much of it was actually functional. So if you want to point at something in genetics, whether it's pseudogenes or junk DNA or something else, the same principle applies. The problem of induction is a reason why we can't say that it's absolutely true. Now, about these particular fields.
Thank you.
So whether it's genetics, biochemistry, linguistics, biogeography, anatomy, or the fossil record, each of these, when it comes to human chimp ancestry, this is still based upon homology. Now, homology is the assumption that similarities, whether at genetic or anatomical or biochemical level, are due to common ancestry. That is an assumption. Now, for someone to say that it is a fact, what they're basically doing is they're assuming that there is an argument to be made. Now, the argument which is actually put forward goes like this, and I want Phil to tell me whether he agrees with this argument. Similarities are due to common descent. Hey, look, similarities exist. Therefore, we have evidence of human chimp ancestry, or therefore we have evidence of homology being true. Do you agree with this argument?
No, of course not.
You don't?
No one in evolutionary biology thinks that, right?
Okay.
That's just ridiculous.
So you don't believe it's a fact then?
No, I believe human chimp common ancestry is a fact, but it's not a fact just because humans and chimps are similar. No one is saying.
That's fine.
Right. No one is saying because they're similar, therefore they have a common ancestor.
Sure. So the
in fact, if you listen to what I said, we're actually looking at the dissimilarities as well as the similarities.
Sure.
There are subtle patterns between similarities and dissimilarities. So if you take nano-P8 is not in the chimp genome, right? We don't, right? So we're not just talking about similarities. We're talking about the dissimilarities as well. But there are consequences of the similarities and the dissimilarities. The way you assess this is the theory makes a number of precise predictions, and then using very parsimonious assumptions.
Yep.
Then, again and again, if you keep finding that the predictions are found by the evidence, then you say that theory is true. Okay. Now,
wait.
Hang on. Let me just come on to what you said. Hang on. I want to address what you said.
Sure. But I asked a particular question, which is, I summarized what you said there in an argument. I want you to tell me whether this argument's correct or it's incorrect.
Okay. If I understood what you said correct, then maybe I misunderstood you. But as I understood...
Do you want me to repeat the argument?
No.
Okay, sure.
Well, I'd say what I understood as you to be saying. You were saying that it was based on an assumption of homology, yeah? And that's false. That's not true at all. Okay?
Okay.
Let me tell
so
you why
human chimpanzee history is not based on homology.
It's not based on an assumption of homology.
It's not based on the assumption of homology.
Correct.
Okay. So
it's based off of evidence.
Sure. So tell me this.
We don't start with the assumption of homology and then conclude homology. Of course not.
Okay.
Right?
So here's the thing. When you go out in the world and you look for a genetic similarity between humans and chimps, or an anatomical similarity, or a similarity,
or dissimilarity, we're talking
whatever.
What
are you basically looking for?
Okay, we're looking for evidence of common descent.
Based on
the predictions that theory makes.
And what's the predictions?
Okay, I just gave some predictions.
Sure.
Right.
Which is homology.
Okay. No. Homology is the conclusion. It's not.
No. Homology is an assumption.
Okay. No, it isn't. Okay. Let me just explain to you why it isn't. Okay.
Sure.
Right. Okay. Because we have some traits that are similar because of homology. Right. We also have some traits that are not due to homology.
Fine.
This is convergent evolution. Yeah, homoplasia is the cladistic term, but a more general term would be convergent evolution.
But there's a difference between these two terms.
Okay, but the point is the same, right?
No, it's not.
How is it different?
Okay, so when you have convergent evolution, you are assuming that common ancestry is actually true, right?
Well, okay, I mean, yes.
So when it comes to the initial point which I made, which is that you begin off with an assumption, and that assumption is an assumption of homology, and then you look for similarities or dissimilarities. You're saying homology is a conclusion. I'm saying homology is an assumption. Now, I'll give you evidence why it is actually an assumption and not a conclusion. Erasmus Darwin, Darwin's grandfather, he believed human chimp ancestry. He believed in it, okay? Yeah. Now, what was his evidence for human chimp ancestry?
I wouldn't have thought he had any evidence for human chimp ancestry. I didn't know Erasmus said that. Maybe he did. I don't know.
Okay.
But I wouldn't have thought
Erasmus
he had much evidence. Okay. Fine.
Now, going back to the Enlightenment, and many of the thinkers of the Enlightenment, just like Erasmus, they believed in human chimp ancestry to be true as well. And this goes all the way back approximately 3,000 years to the ancient Indian philosophers in the Indus Valley. All of these people, including the Greeks, the early Greeks as well, they believed in human chimp ancestry as well, human primate ancestry. This was based on the assumption of homology. Now what Darwin did is he came along and he put fuel on the fire by giving them a mechanism by which you can have transformation. So homology is an assumption, and for that assumption, for human chimp ancestry, for it to be taken as true, you need to have an argument. The best argument that you've given me so far, I've summarized, and you need to tell me whether you disagree with the premises or whether you disagree the premises leading to the conclusion. So let me repeat it for the benefit. One last thing. Let me repeat it for the benefit of the crowd here. Similarities are due to common ancestry. That's an assumption. Hey, look, similarities exist, whether it's a pseudogene, whether it's something in genetics, whether it's something in linguistics or whatever. Therefore, common ancestry is true. I want you to tell me, do you disagree with the premises or the conclusion?
Okay, what I would say is I disagree with your premises. Okay, you don't start. I mean, there may have been people that thought. Hang on, let me finish.
Sure.
You spoke and
Sorry.
Interrupt you, okay, right. So it's certainly true. There are people that thought human chimp common ancestry was true before we have the evidence. That's true. Okay, but when you go and do the genetic tests, right? When you do the genetic test, you don't know what the answer is. The genetic tests give you an answer though. Okay? So you can go in there, doing that experiment, you can do that experiment without any presupposition about whether human and chimps have a common ancestor or whether they don't. So if you take the example that I gave, notice that Suboor did not really counter any of the evidence that I actually presented. Hang on, please don't interrupt, right? Okay? I said, if evolution is true, then we should find that nano-P8 is the youngest of all the nano-pseudogene.
Which is homology.
Okay? but homology doesn't tell you which of those nanogenes are the youngest, does it?
Yeah, but you're using homology.
But it doesn't tell you which are the youngest. It
Okay.
doesn't tell you a date,
Look,
does it?
Phil, you're making an argument
it?
which is that genetics has given us something new.
It's not me giving the argument. This is what
No,
all of the people on the Chimpanzee Genome Consortium said. Okay, don't make this about me, right?
But
Okay,
this is your interpretation of what they're saying.
Okay, well, it's damn clear what
Okay,
they say.
so Phil, tell me this.
Spectacularly confirmed.
Sure, so
that's what they said.
Okay. That's not what they
Right?
said.
Now, hang on. Yes, it is what they said.
Okay,
I'm
one
sorry.
sec.
I'm sorry. I'll pull it back up just so you can. You tell me what they. You read that out. Hang on. Read that out. Where it says more than a century ago.
What paper is this?
This is, I told you, initial sequence of the chimpanzee genome in comparison with.
And
the
what
human
is that?
genome.
What is that? Comparison, which is homology.
Yeah, but you're comparing to see whether homology is true or not.
You know-
And the data could come back not, couldn't it?
Yeah, but hang on a
Right,
second.
is it true or false that the data could come back and say not homology?
You put the cart before the horse. Let me explain
I haven't.
let me just explain what's going on here. When you go out and look in the world,
Yeah.
there's no such thing as looking at scientific evidence, observations, and then coming up with a hypothesis. That doesn't exist.
What?
You don't go out in the world, look for observations, and come up with a scientific hypothesis.
Really?
No. What you do is you start off with a hypothesis, and then you go out and look for evidence.
It goes both ways, but that's
Okay,
beside
well,
the
one
point.
second.
I
So
can give you examples. That's the other way
Darwin
around.
himself, what he basically said is this. He said if science doesn't proceed by beginning off with a hypothesis and then looking for evidence, then you might as well go to a quarry and count pebbles. Now this issue is a well understood problem in the philosophy of science, that you have the theory ladenness of observation because of this issue. Now, when you are doing a study like this and you say we've come to a conclusion, that conclusion starts off with an assumption, as it does in the title of the paper, which is the assumption of homology, comparison.
That's not
One
in the
last
title
thing,
of the paper at all. That's false.
comparison.
But they're comparing. So
Comparing what? What are they comparing? Me and the tree, or are they comparing
They're
humans
comparing
and chimps?
humans and chimps.
Which is homology.
No.
That's
No.
not homology?
No, it isn't. Because homology is, okay, let's explain to those people that aren't familiar, right? Homology is defined, well, the definition of homology has changed over time, okay? So before it was just similarity, okay? Now we think it's similarity due to common descent. That's how the homology is
Okay,
generally understood.
that's not
Let
quite
me
true.
Let me finish, right? Okay? But this is the important point. The important
Every
point...
point's important.
No, because some are trivial, right? Some are less trivial,
Sure.
okay? Right, so the point is, there's nothing in the title of the paper that says anything about homology.
What?
Okay?
Read the title again.
Initial sequence of the chimpanzee genome and comparison with
Comparison.
the human genome.
Comparison
Right,
of
so when
genomes
you
is homology.
Okay, no, but it's not.
'Cause
I'll tell
you're
I'll explain
comparing
why, I'll
to-
explain why. If they're homologous, then we look to see, take the example I gave, we look to see if they're homologous, then nano-pH should be the youngest of the pseudogenes.
Yep.
We don't know that ahead of time.
Yep.
We do molecular clock data,
Yep.
and then we see, is it homologous or is it not homologous?
Yep.
Okay? It's not decided ahead of time.
Yeah,
Now,
but the
of
assumption
course-
is there though.
Okay, yes, the assumption's there. I don't
Yeah,
disagree with
yeah.
that.
And that
The
assumption,
is there.
so you
But-
previously said it's a conclusion or an assumption.
No, what I'm saying is, you're misconstruing what I'm saying.
No?
What I'm saying is that you don't just derive homology from an assumption of homology. What I said was...
That doesn't make any sense though.
What I said is that you derive common ancestry from the evidence, not from the assumption of common ancestry.
Okay, so
Okay? I'm not saying no one ever
Okay,
assumed there was
sure.
common ancestry.
So
Okay, obviously they did.
let's delve down to
Right.
genetics.
Okay.
Do you think genetics gives evidence for human chimp ancestry to be true literally?
Well, it depends what you mean by true literally.
Forget
okay?
that. Do you think it's evidence?
Yes, of course.
Apart
it
from
is.
homology.
It's spectacularly.
Okay,
it's
so
strong
tell me
evidence.
this. Is that anything apart from homology?